Hi class, so I know you're all going to be super thrilled to hear that we are starting into story problems. I know it's always my students' favorite unit, of course, right? We all should have a copy of the notes. Hopefully you grabbed that from class yesterday, but if for some reason you don't, it is linked on Canvas. Don't feel like you need to print it. You could just write down the major things and then get a copy from me in class. Okay, so today we're just looking at basic translations. One of the key things to being able to do story problems is to just recognize key terms that tell us what we might need to be doing. So what I've gone through here is just made a list for you of some of those key terms that we work with when we're dealing with story problems. So the first thing that we see up here is the phrase, a number. So whenever we read something that's just talking about a number, that means the value of the number is unknown and we need to translate it into a variable. You can choose whatever letter you want. I suggest you choose a variable that you're willing to solve for. So if you're choosing Q because you feel sorry for it, but then you don't like to solve equations with the letter Q in it, don't pick Q. Is represents equals, right? Equals also represents equals. Is equal to also represents equals. The quantity, this is a really big one that my students often don't know. The quantity is telling us that something is being grouped together and we need to use parentheses. Now, we don't always need to use parentheses because there are times that parentheses are just understood, but if you're not sure, you can put parentheses in. Now, when we're translating a word problem, the order of the translated equation that we're writing is going to be in the same order that we read it. So if we read a number, we'll write down a variable. If we read is, we'll write an equal sign. But there's two situations that force us to change the order. Okay, so we need to change the order if we read less than or if we read subtracted from. And these are the two that my students struggle with the most. They know that less than tells us to subtract, but they forget that it tells us to change the order. So if we read 11 and we write down 11, and then we read less than, we don't want to put the subtraction after it. We need to put the subtraction before it because we are reversing that order. And so we'll end up with x minus 11. The same thing is true for subtracted from. Okay, so 11 subtracted from a number tells us to change that order as well. Now, if you think about it, your brain actually does that pretty naturally. If you stop thinking about it as a word problem and you just think about it as what math you would do. So if I said to you, what is 2 less than 10? You would tell me 2 less than 10 is 8. Well, how did we get 8? We changed the order and we did 10 minus 2, right? 2 less than 10 is 10 minus 2. Okay, so if you're ever not sure, you can sort of just ask yourself a simple situation and see if that sort of triggers your mind. Then down here, sort of on the back of your notes and the bottom of this page, I've gone through and I've listed a bunch of key term words. I am assuming at this point that we should be familiar with our basics. So we should know that sum is addition. We should know that more than is addition. We should know plus is addition. Keep in mind, you could choose any adjective you want. So more than, larger than, bigger than, more ginormous than, whatever, right? All of that is telling us addition. So multiplication is of. This is a big one, right? Making sure we know of is multiplication. We've talked about that in class when we've talked about some distributing. Product, times, right? Twice a number, half of a number, right? That's all multiplication. Subtraction, right? We have difference. We already talked about less than is changing the order. Obviously, we talked about subtracted from. So like I said, this doesn't list everything. It's just some of those key terms to get your brain going about them. So less than, smaller than, tinier than, more minuscule than, right? Any of those types of things. Division, we have quotient, we have divided by. So quotient is different than the quantity. My students tend to get those confused. Now, we also have terms for our inequality symbols. And this is where we need to make sure we're pretty clear, because we're fine with equals as is. Okay, so we have this small piece that we need to look at, because this says less than and subtraction says less than, right? Addition says more than and greater than says more than. But we need to understand that to tell these apart, to know when we're talking about an inequality symbol and when we are talking about an operation, is all based on that word is. Right? Is telling us that we need some type of equal/inequality sign. If it's is by itself, that's an equal sign. Okay? If it's is followed by a little bit of info, that's telling us an inequality sign. Okay, so if we notice, there's a couple on here with our inequality symbols I want to point out. Is less than, no big deal. We've been talking about that for forever, right? Is greater than, again, we should just know our inequality symbols. Is at most. This is a tough one for my students, and they often think that I've listed them backwards, but I haven't. Is at most goes with our less than or equal to. Right, so is at most means I'm going to spend at most $20. If I'm spending at most $20, I can't spend anything larger than that. So is at most is numbers less than $19, $18, $17.50. Okay, same thing. Is no more than, it's not more than. So it's less than. Okay, we then have that flip-flop down here. So is at least means it's greater than or equal to. Right? If I'm spending at least $20, I'm spending $20 or more. Okay. So then when we go to translate these, it's just a translation word for word. So if you think you're super familiar with these terms, you might not need to use this list at all. If you say, ooh, I'm not as good at those terms, you might need to be referencing the notes more. But we're just gonna do this a piece at a time. So if we look at this first one, the sum of a number and 67 is negative 34. What is the number? The key point that I tell my students all the time is to not try and look at this as one big piece. Okay, instead, try and look at this one small chunk at a time, which is what we should truly be doing with any story problem. Try not to look at this as a whole entire thing that just magically you get an answer to, but instead try and look at it one small piece at a time and get one little piece of the translation at a time. So if we look at number 1 here, okay, we're gonna break it down one term as we go. The sum. Okay, so sum we know was on our list. Whether you need to look on the list or whatever, you just know what it is. Sum tells us addition. Now, we see the word of, and we said of was multiplication, and this is where the English language is confusing. Of is also just a word we use in a sentence, so we have to be careful of when it's asking us to do an operation and when it's just part of the vocabulary. So the sum, we already have our operation. That of is not multiplication. Of a number. A number told us to use a variable. So I'm going to pick X. And 67, well, that's pretty straightforward, right? 67 isn't followed by any descriptor, so that's just an equal sign. Negative 34. Now, when we read the words afterwards that says, what is the number? That's just asking us to solve. So this says, hey, take this and solve it. So hopefully we know how to solve this, no problem. We already quizzed over solving equations. So we're just gonna subtract that 67 from each side. Oh dear, sorry guys. That will cancel. And we will get negative 103. Okay, so hopefully we're like good to go. So here we go. Number 2, the product. Product tells us multiplication. Multiplication can be represented as a dot, as parentheses, as nothing. So whenever we read multiplication, we're going to hold that in our brain. Okay? So I know I need multiplication of 8 and a number. So a number, I'm doing a variable. This already represents multiplication, so I don't need to write anything else. Or at most. So at most, right, are and is, same thing. So at most, I'm doing less than or equal to 216. Now, when it says what are the numbers, that tends to throw my students off. But remember, when we solve this, okay, so we do 216 divided by 8, we get 27. When we solve this, n being less than or equal to 27 is more than one number. So it's not is the one number, but what are all the numbers? And it's all the numbers less than or equal to 27. Number 3, 5. So I'm writing down 5. Less than. Less than tells me to subtract. This doesn't have an is in front of it, so I'm subtracting, but it also tells me to change the order, so it's going in front of a number is less than. That's my inequality sign because it has the is in front of it. Twice the same number. So when I'm reading the same number, it's just telling me to use the same variable. It has nothing to do with what I wrote over here. Just choose the same letter. So twice x increased by is addition, 25. And then hopefully we know how to solve this. So we have variables on opposite sides. So I'm going to get them together with the opposite sign. Negative 30. And then when we rewrite with the variable first, x is greater than negative 30.